Hey, welcome. You've probably used AI, maybe a dozen times already today, and you might not even know it. It's in our homes, our cars, our phones. But what is it really? Let's break it down.
I mean, AI is everywhere, right? It's running so much of our daily lives. Think search engines, movie recommendations. But if you look past all the buzzwords and the sci-fi stuff, what's really going on under the hood? That's the question we're going to tackle right now.
So at its heart, the core goal of AI is actually pretty simple. It's all about getting computers to do things that, well, the human mind can do. And that's a huge range from stuff we'd call smart, like logical reasoning, all the way to things that feel almost automatic to us, like just seeing.
Right from the get-go, AI research was kind of pulled in two different directions. On one hand, you had the tech goal. Let's build powerful tools to solve real-world problems. But on the other hand, there was a scientific goal. Let's use AI as a model to help us understand our own intelligence. To figure out how our own brains actually work.
And the seeds for all this were planted way before we even built the first computer. Back in the 19th century, you had Ada Lovelace imagining a machine that could manipulate symbols, not just crunch numbers. Then, in 1936, the legendary Alan Turing laid out the theoretical groundwork. And by the 1940s and 50s, the research really kicked off, but it immediately split into two totally different camps.
So yeah, the history of AI isn't just one single straight line. It's really a tale of two competing philosophies, two totally different ways of thinking about what intelligence even is. You could almost call them the logicians and the biologists.
Okay, so in one corner, you've got symbolic AI. This is a top-down approach. It treats intelligence like a logic puzzle. You're just manipulating symbols based on a set of rules. And it's awesome for things like planning. But in the other corner, you have connectionism. This is a bottom-up approach, totally inspired by the brain. It uses these interconnected networks of artificial neurons to learn patterns straight from data.
And this all led to a huge split, right around 1960. The field basically broke in half. The researchers who were focused on the mind, logic, reasoning, language, they went down the symbolic path. But the ones who were fascinated by life, things like adaptation, biology, how things organize themselves, they stuck with neural networks. And for decades, these two camps pretty much just went their own separate ways.
So how did that first camp, the classic symbolic AI, actually solve problems? Well, they developed a really powerful toolbox of strategies to tackle complex challenges. Let's dive into a couple of the most important ones.
Okay, first up, heuristics. Just think of these as strategic shortcuts or rules of thumb. A great example is in chess. The rule, protect your queen, is a fantastic heuristic. It almost always points you toward a good move. But is it always the right move? Absolutely not. Sometimes the only way to win is to sacrifice the queen. So a heuristic guides you, but it's no guarantee.
And that brings us to another key tool, AI planning. Imagine you're packing a suitcase for a trip. The final goal is clear, a packed bag. But the steps? Not so much. An AI planner breaks that main goal down into smaller sub-goals, like gather all the clothes or buy sunscreen. Then it has to figure out the most efficient order to do things. Do you put each item in the suitcase as you grab it, or do you make a pile on the bed first? It's all about creating a step-by-step logical plan to get from A to B.
But, that suitcase example brings up a massive problem. You and I just know you don't pack a leaky bottle of sunscreen next to your favorite shirt. We don't even consciously think about it. But how is an AI supposed to know that? This is what's called the frame problem. It's this huge challenge of how you teach an AI the practically infinite list of common sense things about the world that we humans just take for granted.
All right, let's switch gears completely and talk about that other camp, the biologists, and the modern revolution they kicked off, machine learning. The big idea here is, instead of writing a bunch of explicit rules, you design systems that can learn for themselves, directly from data. So let's see how this works with deep learning. Let's say you want an AI to spot a cat in a picture. It doesn't start by looking for cat features. No, it starts way more basic, at the absolute lowest level, the individual pixels. The very first layer of the neural network takes in all that raw pixel data and just learns to spot super simple patterns. It's not looking for a nose or an ear yet, it's just finding the most basic building blocks, things like horizontal lines, vertical lines, little curves and edges. Then, the output from that first layer gets fed into the next layer. And this second layer starts combining those simple lines and edges into slightly more complex shapes, maybe something that looks like an eye or a whisker. And then the layers above that combine those shapes until finally, way at the top, the
the network can put it all together into the abstract concept of a cat's face. It's like a pyramid of pattern recognition, building up from simple to complex.
And the sheer power of this approach really hit home back in 2012. Researchers at Google built this massive neural network and just showed it 10 million random thumbnail images from YouTube videos. Here's the kicker. They never told it what to look for. And yet, after just 3 days, one of the artificial neurons in the network had taught itself to become a highly reliable cat detector, all on its own.
Okay, so AI has clearly gotten incredibly good at pattern recognition. But what about the stuff that feels uniquely human? Let's take a look at the frontiers where AI is still really struggling.
Take creativity, for example. It's not just one thing. There's what you might call combinational creativity, mixing existing ideas in new ways, like making a cool collage. Then there's exploratory creativity, generating new things within an existing style, like writing a new song that sounds like Bach. AI is getting surprisingly good at both of those. But there's a third kind, transformational creativity. This is when you invent something so new it rewrites the rules of the game, like inventing jazz, and that still seems to be a deeply human thing.
And what about emotions? We usually think of them as the opposite of cold, hard intelligence, right? But some AI researchers are starting to flip that idea on its head. This quote here suggests that an emotion like anxiety isn't some kind of bug in our system. It's a feature. It's a computational mechanism that helps us manage a messy world with all these competing goals, helping us figure out what to focus on when everything is screaming for our attention at once.
And all of this leads us to the ultimate goal, the big, ambitious dream that's been driving AI research from the very beginning. It's what some people call the holy grail of the field.
And that goal is artificial general intelligence, or AGI. We're not talking about an AI that's just a master at one thing, like chess or spotting cats. We're talking about a truly flexible, adaptable system that can weave together all sorts of different abilities: vision, language, logic, learning, to tackle brand new problems it's never seen before, pretty much like a person can.
So, as we've seen, the path to AGI is definitely not a straight line. If this whole journey has taught us anything, it's that intelligence isn't just a single mountain to climb. It's a vast, complex landscape. And to really navigate it, AI is probably going to have to finally bring its two halves back together, combining the crisp logic of the symbolic guys with the powerful pattern matching of neural networks. And even then, it's still got to solve those massive fundamental problems, like common sense and the frame problem.
So after pulling back the curtain on the science behind the hype, we're left with the ultimate question. As we keep building these incredibly powerful machines, are we actually on the path to creating a true artificial mind? Or will AI always just be a spectacular mirror, one that reflects pieces of our own intelligence back at us, but never truly possesses it? That's a debate that is far, far from over.